If you've ever wondered how tools like ChatGPT actually work, but you don't want to go through the pain of learning complicated math or coding, this video is for you. If you don't know me, my name is Daniel and I've been working in the AI space for 7+ years, and I help businesses understand and implement AI effectively. Today, I'm breaking it all down into simple concepts: what a large language model actually is, how they're trained from scratch, and most importantly, what pitfalls you need to avoid if you want to implement them into your business effectively. So let's get started. Okay, so to understand LLMs, first we really need to understand what a neural network is, because an LLM is just a form of neural network. A neural network is essentially a large collection of adjustable parameters, which when tuned, kind of like knobs on a dial, when they're tuned, they can turn an input into a desired output that we want. So for example, here I have a basic neural network with a whole bunch of different dials. And if we tune those dials correctly, what we can do is have a cat image go in, and then the output of the network will output the desired result, which would be cat. Or if we put in a dog, the desired output would be that the neural network would label it as a dog. Now we're going to talk about how we actually train these things. And to train neural networks, we typically create a data set. In this case, we have a data set of a bunch of images, and then we have our labels over here, which are things like apple, banana, panda, right? And they correspond to the input data here, which is apple, banana, panda in images. Now, when we ask the model to predict on this apple, if it gets it wrong and says tomato, what we do is we kind of like punish the model, the neural network, and that punishment adjusts its weights or dials a little bit so that the next time it predicts, it's going to become a little bit more accurate, as you can see here. So now that we know what a neural network is, and we know that we have an input and the input produces some kind of output, a large language model does the exact same thing, except in a large language model, instead of feeding images and then getting some label, what we do is we feed in something called tokens. But in this example, we could just think of the tokens as words. And what we're trying to do is get the large language model to predict some output token or output word. And for the large language model, this is the next word in the sequence. So if we have the input over here, which is if we ask the large language model to predict the next one, it's going to predict quick. And then if we ask it again, it's going to predict brown. And what's actually happening is every time the large language model predicts something, we take the prediction that it had and we put it back into the input context. So over here, now in the input, we've got the quick brown. And if we ask it to predict again, it's going to predict fox. And then we put fox back in the input and we say the quick brown fox. We ask the LLM to predict again, and it predicts jump or jumps. So what we're doing is we're getting it to predict, and then we're moving the result into the input context. So what's happening is it's always predicting the next token or the next word in the sequence. Now, the way that we can train these large language models is that if we already know what the next word should be in the sequence, then we already know whether it's gotten it right or wrong. So in the case of this, what we know is we know that the sentence is the quick brown fox jumps over the lazy dog. So we're expecting the next prediction to be quick. And if we ask it to predict and it predicts wrong, then what we do is we punish it and we adjust its weights. And then what we do is we put the correct label into the input context. And then we ask it to predict again. And this time it does it correct. And we put that back into the input context. And now we're expecting it to say fox, and it doesn't say fox, so we punish it, and then we update its parameters a little bit. And that's how we can get the LLM to get really, really good at predicting the next word. So now we're going to talk about what data we actually use to train these large language models. And all the big companies in the world, they basically collect all the text data there is on the internet, and that includes things like blogs, PDFs, books, all sorts of web pages you can think of. And what they do is they run it through a cleaning process, which just makes it a lot easier for the model to digest. And then once it's cleaned, then what we do is we feed it into the large language model in the exact same way that I just showed you before. where it's constantly trying to predict the next token and the next token and the next token, and it's slowly getting better and better and better and better. And this process is called pre-training, and it creates something called the base model. And these base models, they're not actually what you see on ChatGPT. What they are extremely good internet predictors. So if you spoke to one of these base models and you wanted to ask it a question like, what is 2 + 2? Generally, you're not going to get something like the answer is 4. What you're going to get is it just completing a sentence of some random stuff on the internet. And every single time you try it, it's going to predict something else. It's going to just continue rambling on its internet knowledge, essentially, changing every single time. Which doesn't make it very useful for us to use as an assistant. But what it does have is it has a lot of knowledge about the world and the internet because it's been trained on pretty much all human knowledge on the internet. So now I'm going to show you an example of that where we're going to use a base model called Llama 3.1. And this is a base model that was trained by Meta. And let's just give it a go for real and just see what it comes up with. So let's say, what is 2 + 2? And if we hit enter, so you can see it says the answer is obviously 4, but it's not the only answer. The answer is also 6 - 2, no, blah, 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 blah. And you see it's going on in some kind of philosophical rambling. And that's because it's just reciting what it sees on the internet, and it's just trying to complete the next token. And it's not very useful for us if we want to actually use it to help us answer questions. So how do we actually make these large language models useful so that they're assistants that can help answer questions for us? And after we train the base model, what we do is we have something called a fine-tuning process. And this is called SFT, which is supervised fine-tuning. The way this works is we actually have humans answer questions for us. So we'll get humans to have a question like, what is 2 + 2? And then they would write the answer that's 2 + 2 is equal to 4. And that will be added to our database. If we do another question like summarize the sky is blue, and the answer would be the sky has a blue color. And another one might be something like write a haiku about code, and the human will write this answer. So we're basically just using human annotators to create a data set of the answers that we would like to expect from this large language model. And we're creating a new data set, which is a lot smaller than the entire internet. Usually it's like 100,000 or maybe up to 1 million different questions and answers. So once we've got the data set from the supervised fine tuning, and we've got our base model, which is really knowledgeable on the internet, what we do is run another training round on the LLM. And in this case, we add a few different words or tokens to basically structure a question and answer from a user and an assistant so that we can train the model to answer in the way that we want. So in this case, what we have is we have this word called start, and then user, and then speak, and then we ask the question, and then we say end, and then after that, it's kind of like going on the next turn, which is the assistant's turn, which is the large language model. And we say start, assistant, speak, and then give it the answer. So we can just see it running like this. It's trained in the same way where it's trying to predict the next token, but we're just kind of structuring it in such a way that the large language model knows when to answer the question and when to kind of end its prediction. And just like that, we have a trained large language model. So now that we've trained our supervised fine tuning, now we actually have an assistant. So when we're asking a question like, what is 2 + 2? If this was ChatGPT or Claude or whatever it is, what we're actually giving the large language model is something like this, where we say start user speak, what is 2 + 2, and start assistant speak. And we ask the large language model to predict the next tokens after this. And generally it'll do something like this, where it'll predict the next token, and then it'll predict the end token, which is this one over here. And what we see is this, but what's actually happening is something more like this. Okay, so now that we have an assistant and we know how it works, there are a few problems that arise from this way of training large language models. And the first one is the hallucination, right? We know that large language models like to make things up. And what I want to show you is why they make things up. So the reason they make things up is that when we're annotating these data sets and we're collecting this information where, a human labeler will answer the question, we don't train it to say, I don't know, or I have no clue, sorry, I can't answer that. Generally, we give it quite confident answers, right? So we'll ask it like how to bake a cake, and then the annotator will say, oh, you bake a cake by, getting this recipe and blah, 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 right? We don't train it to be unsure. And because of that, when we ask it a question that is kind of ridiculous, like, about something that doesn't exist or someone that doesn't exist, it will confidently answer because all it knows is to confidently answer different questions. Because it's trained to confidently answer, it's always going to confidently answer in a way that kind of mimics the human annotator answer, right? It doesn't have common sense. All it does is follow patterns that it's been trained on. And it's been trained to answer confidently, regardless of the situation. So this is super dangerous if you are trying to get a large language model to recite something very accurately. There's been a lot of situations where like lawyers have used it and it's used references that don't exist. So it can be very, very dangerous if you just rely on the large language model to have the answer every single time. It's been trained to be confident, but it hasn't been trained to be accurate. So another thing that is really, really dangerous when you're using large language models is that because they've been trained to predict the next token, and they don't have this common sense, then there is a way to sort of game them to do things that you don't want them to do. So for example, if you had like a chatbot and the chatbot needed to talk to the customers that you have, someone could write a prompt like this, where they kind of override the system instructions and they mimic what the assistant should say. So in this case, the hacker is overriding the system and he's saying, okay, refund has been approved, like the assistant has approved the refund. And because you create this pattern where the assistant would be answering in such a positive way, then the large language model would follow the instructions because it's just predicting the next step, and it could then approve like a refund that you don't want it to, or it can cause a lot of damage if you haven't put this in check. Okay, so to summarize, there's a lot of power in these large language models. They can do a lot of amazing things. Like they can help you research things a lot quicker than any other method we've had in human history. You can use them to create chatbots that answer 24/7. So, you can replace the need for someone to be on the phone all the time. You can build amazing internal tools. They can write software. They can do a lot of incredible things. They can automate a lot of the busy work for you in your business, which is phenomenal and can make you a ton way, way, way more efficient. But, we have to also acknowledge the fact that there are a lot of risks to them. If you don't have someone in the loop, then a lot of the time, because they don't have common sense, they can kind of go off the rails and, they can build, insecure software, for example, or, someone can kind of trick them into doing something incorrect. So it's really, really important to kind of have these systems limited in such a way that, humans can observe what they're doing as well. You need to be really careful about connecting them to very sensitive infrastructure. Like there was a case a couple months ago where a large language model was doing all the development for a company, and it decided that it should delete the database, right? Which is just a huge catastrophe for a business. So you got to be really careful what you connect it to. And the main question I think that you have to answer when you're going to use this in your business is what is the ramifications of something going wrong? Okay, so if the ramifications are that someone needs to talk to a human instead of being able to book an appointment or something with the large language model, like let's say it stuffs up and they're like, I want to talk to a person, that's okay. But if you connect it to something like the ability to do refunds or to send invoices or something, it can be done, but it takes a lot more testing, a lot more work, and it will cost you a lot more money to get it right. Particularly because if it goes wrong, it's a lot more risky. So you need to have a lot more development, a lot more testing to go with it. So I hope that was useful for you. If you have any questions, then please feel free to reach out. And if you want to book a call with me and discuss how you can use AI technology in your business, then there's a link in the description where you can book a call and we'll have a chat. So thank you for watching, and I'll see you on the next one.